Okay. So by the time others join, let me explain you the basic structure of this course. So this is course titled Form Work and Enabling Structures. It has 3 credits. Each credit corresponds to 50 grade points. So there are total 150 grade points associated with this course. Out of these 3 credits, 2 credits are allotted for theory, 1 credit is allotted for lab sessions. So therefore 50 grade points are allotted to theory and 100 grade points are allotted to theory and 50 grade points are allotted to lab. So lab continuous assessment for this course, lab continuous assessment, it will be for 50 marks. Then in theory, you have 2 heads for assessment. One is class continuous assessment, which we call it as CCA, and that will be for 50 marks. And you are going to have end term examination, we will call it as ETE, that will be for 50 marks. Mind you, this time in all likelihood the examination is going to be offline. So I request you to carefully take notes of this course as we go along. There is one request to all of you. When you join the class, please join it by roll number underscore name. Few of you have joined today with this format as a display name. Others, for today it's all right. From tomorrow you should join the class with roll number underscore name. For example, PA67 Shankar Dudre. So that's how you should join the class. Now this was the background of the course, introduction to its structure and assessment. Now we will go ahead. You haven't received your roll number. Okay, you can write your previous roll number till the time you receive this trimester's roll number. I hope that should solve the problem. Then regarding marking of attendance for this course, I am going to create a Google link, Google form. This form you will be filling within the 5 minutes of closure time of the lecture every day. So जिस दिन lecture रहेगा उस दिन आप वो link fill करने वाले हो. Once you fill that link, I will understand that you were present for the class. So with this background, now let me ask one of you to unmute. Let us say Raj. Raj, can you unmute yourself? Roll number 11. CD.
Yes, sir.
Okay. So today, in today's class, we will have a discussion as we go along with this course contents. So before even we give introduction to form work and enabling structures, let us try to first understand few prerequisites and we will try to revise some things. So we will start with the question, what do we understand by word design? So you can start, Raj. What is your understanding? What is design? And to be specific, I want to call it as structural design. Yes, go ahead. Yes, Raj.
Structural design means a specific layout or some thing for the work to be properly carried out.
Okay. So Raj says it is layout. Anything else you want to add, Raj?
No, that one.
Okay. Now let us go to Dhruv. Dhruv, can you unmute?
Yes, sir.
Yeah. So what is your understanding of structural design?
It means to create something.
Create something. Isn't it very vague? Can you be more specific? Okay, let us go to Varda. Varda, can you unmute? One ground rule for this course.
Sir.
Yeah, just a minute. One ground rule for this course. If I announce your name, you have to either respond in chat or you have to respond by unmuting yourself. Otherwise, I will consider you as absent and you will be shifted to lobby. Yes, Varda, go ahead.
Sir, these are the bones and muscles of a building.
No, that is linguistic. No, can you be more specific? What do we mean by structural design? What do you do in structural design? You have undertaken two courses in design. One is design of RCC structures and one is a design of steel structures, if I'm correct. So what did you
Yes.
do in that? Yeah.
Provide specifications for the various structural members.
Specifications in terms of,
What type of bar to use, what diameter, and what not.
okay. So specifications of members, he means the quantity of steel. Is that what you are trying to say?
Sir, the type of steel to be used and the diameter of steel to be used.
Yes. So ultimately it is quantity and type of steel, right? And if you are saying it for steel, you are also saying it for concrete, right?
Yes, sir.
Okay. So quantity of steel, its placement, spacing, whatnot, diameter, then grade of concrete, all these things, right? Okay. Anyone else has any other idea? Let me
Sir, structural design means designing these structures like steel and concrete for its the designed load bearing, the load which is to be applied.
Okay. So so it should carry that load successfully. That's what is designed, right? That's what you mean. Okay. Now let me ask some few more people. Let me ask Prajwal. Prajwal, can you unmute? Prajwal Singh.
Yes, sir. Good morning, sir.
Yeah, good morning. So, apart from these points listed here, what can you include in the definition of structural design?
Yes, sir. No.
Okay, let me
So,
open now this. Yes, go ahead.
so it is the basic layout and planning, which is to be carried out for the
Okay.
building procedure.
Okay. So with this now, let me open this forum to anyone who wants to come in. Layout of a structure to be made along with the specifications of materials. Yes. So I have listed both the points. Anyone else who wants to specify something more than this? You can unmute and let me know. I will wait for a couple of seconds and then we will start discussing actually what the structural design is. So
Sir, we
anyone?
analyze the structure in terms of its load bearing capacity, its flexural strength, and its other specification.
Good. So capacity in terms of flexion.
Sir,
Yeah.
structural design is investigation of strength, then
Okay.
stability and rigidity of the structure.
Strength,
Stability and rigidity.
stability, and rigidity.
Yes, sir.
Okay. Anyone else? Okay. So if there are no further responses, let us now try to look at each of the answer, each of the points that are given by the class one by one. So somebody said that it is the structural design is a layout and plan. So while I do that, I need Raj to be unmuted. Raj, are you there? No, no.
Yes, sir.
Yeah. So layout, somebody said that it is layout and planning. So I believe that they are talking about domains like architectural planning, that is space designation. For example, you know the area in which you want to build a structure, so you designate different spaces. For example, let us say it is G+3 building, then you designate some place for living, then bedrooms and other things. So all this layout planning comes under two heads. One is called as survey, and possibly the other one is called as functional design of the structure, functional design of a structure. So we omit this point from structural design because layout and planning is not a part of structural design. It is a part of functional design. Are you with me, Raj?
Yes, sir.
So we now start distinguishing between functional design of a structure and structural design of a structure. So functional design means bifurcation of spaces, its utilization, their interconnectivity. Laying out those places on the site is surveying. Are you with me? So this is a different domain. So we will omit the first point from the definition of structural design. For a structural designer to design a structure, we have been given these details. So this is input for us. Are you with me? Raj, are you with me?
Yes, sir.
Okay. Then somebody said create something. Yeah, that is means no much comments on that. That is a vague answer, but it's right. Means we do create something, but it's all right. Now specifications of members. Somebody said that quantity of steel, type of steel, then bar diameter, its spacing. Then it's let us say for example you also have stirrups, ties, design of their diameter, their spacing, everything. Yes, all right. So all that comes as an output of design. Are you with me? So when we say when we try to define a design of a structure, the outcome is the specifications. Somebody said it must carry the load it is intended to. That's right. That is design. And somebody said some things about the capacity. That is also correct. That is also a part of structural design. And somebody rightly pointed out structural design has something to do with strength, stability, and rigidity. So yes, these three aspects are the most crucial aspects for design. So finally, with all these points that the class has listed down, let us now formally define what do we mean by design. Mind you, this definition is ever evolving. No one can give you the correct and complete definition of design. It keeps on evolving. So for that, at least let us try to come to consensus on what basically at least few crude guidelines to define the task of a design. So what is structural design? So as rightly pointed out by someone, first of all, whatever structure that you are trying to design, you must ensure that its configuration is stable. This is the first task in the hands of structural design. For example, let us say you are designing a bridge and you are going to go for a trussed bridge. So in that case, you must come up with the configuration of truss which is stable. For example, if I come up with the configuration like this, you will understand that of course these are hinges everywhere. If this is the configuration that I come up with for a trussed bridge, then you all of you will agree that this is not a stable structure. Are you with me, Raj?
Yes, sir.
So how do we make it stable? So we need to add members like this. The moment I add this kind of members, then the structure becomes stable. Are you with me?
Yes, sir.
Okay. Let me give you another example. You will find this example which has already taken place, a case study of a building in Japan, where after the earthquake had occurred, the soil went into liquefaction and the foundation lost its stability. The entire building did sink by amount equal to height of one story. There was no single crack anywhere in the building, not on any beam, not on any column. There was no structural damage, but the structure lost its stability. Why did it lose its stability? Because this liquefaction was not taken into consideration while designing the foundations. Are you with me?
Yes, sir.
So therefore, the first and foremost task in the hands of structural designer is to make the structure stable. Are you with me? Chalo, ab aage chalte. What is the next step? So somebody said that the structure must be strong enough to carry the loads it is intended for. For example, let us say you are building a structure in Himalayan region. So it must be designed for judicious combination of dead load, live load, earthquake load. So I'm just going to list down few types of loads here: dead load, live load, earthquake load, wind load, fire load. You are also going to have snow load, in particular cases. So these are the various types of load. The list is unending. Depending upon the circumstances in which you are building a structure, you have to consider judicious combinations of these loads. And you must design structure in such a way that it is strong enough to carry the most critical combination amongst all these loads. If it is so, how will you make sure that the structure is going to carry these combinations of these loads? So you will have to talk about the material that you are going to use, and you will have to talk about the proportioning of sizes of various elements. For example, let us say you are using M20 grade concrete and you are using Fe415 steel. But to carry a particular combination of load, you will have to also come up with how many bars are you going to use, what is the cross-sectional dimension, what is the width of a beam, what is the depth of the beam, what is the thickness of the slab, what are the planned dimensions of column, what is the dimension of foundation. So all this dimensioning and proportioning of material in various elements in order to make structure strong enough to carry the critical combination amongst these loads is the task at designer's hat. Am I very clear?
Yes, sir.
Okay. So we must make it strong enough to carry critical combination. So material choice, I will write down few words here. So material, choice of materials that you are going to use, and proportioning. Proportioning. Now I will discuss an interesting example. Merely proportioning won't do. For example, let us say we have come out with the size of column as 200 mm by 300 mm. Are you with me?
Yes, sir.
Now, can you tell me this column has bending capacity, maximum bending capacity about which axis? I am going to draw two axes passing through the centroid of this column. This is a plan of column. So let us say this is a plan of a particular column under consideration. And this is the centroid which lies on the bisection of diagonals because it is rectangular cross section. And I am going to draw two axes. One axis I am going to call it as axis XX. Another axis I am going to call it as axis YY. The axis perpendicular to the plane of board along the length of the column, I am going to name it as Z. Are you with me?
Yes, sir.
So if I were to draw 3D view of this column, it looks something like this. This axis is Z axis. Then axis that bisects the depth or greater dimension is X, and axis that bisects the smaller dimension, I am going to call this axis as Y. Now imagine that whenever earthquake occurs, it never occurs parallel to a particular face of a building. ऐसे हो ही नहीं सकता. Earthquake के हमेशा दो components रहेंगे. One along a face of a building. So let us say that this is the plan of a building, and this column lies at this location. So I will name this column as C1. Are you with me?
Yes,
This
sir.
plan of a building. So this building may have a staircase here. Let us say. Then it is going to have a cluster of apartments. Those apartments are shown here. This may be a passage, whatnot. And this column C1 is the corner column. Are you with me? Are you able to imagine this plan?
Yes, sir.
Okay. And let us say the earthquake occurs in this dimension. That means ground is going to shake in this dimension. So we will have to resolve the motion in two components. One along the building and another across the building. Do you agree with me?
Yes, sir.
Okay. Now, due to the motion along the length of building, that means this one, let us say the moment that is generated on this building about this axis is, let us say, 20 kilonewton meter. I am just giving a random number, and due to this motion, the moment that gets generated about an orthogonal axis, that has come out to be 30 kilonewton meter. Now my question, how will you orient this column? 300 dimension, will it be parallel to the shorter side of the building, or will it be parallel to the longer side of it? Can anyone answer this question? देखो, earthquake के वजह से moment कैसे आ रहा है, तो imagine that the moment about one of this axis is m1 and moment about this axis is m2. And in this particular case, I will say m1 is 20 kilonewton meter and let us say m2 is 30 kilometer, 30 kilonewton meter. How will you orient this column? Will you have this face, longer face, along the longer face of building, or will you have shorter face along? That means, will you orient the column in this fashion, or will you orient the column in this fashion? Are you able to understand my question?
Longer sides are parallel to the longer.
Okay, so I will not answer this question immediately, but you will have to understand it has to do something with the moment of, it has to do something with I of this cross section, moment of inertia of this cross section. Are you with me?
Yes, sir, we are.
Yes, sir.
So about which axis you have greater moment of inertia, that should the greatest bending should be about that axis. This is the philosophy. That's how we orient. So we have to also understand that when we talk about the strength, we talk about the deadliest load combination, first thing. Then we talk about choice of materials. Not only that, we talk about the proportioning of the cross section. We also talk about orientation of the cross section. Are you with me?
Yes, sir.
Yes, sir, we are.
So few tasks I have listed down. This list also is unending as we progress, as we go ahead in this course, or you learn different courses pertaining to design, then you will go on adding to this list. I am just giving you the flavor of what we are trying to do when we are trying to make the structural element or building strong. So a designer has two Herculean tasks. One is he has to make the structure stable under all type of situations for its design life. Second, the structure should be strong enough to carry out deadliest load combinations throughout its design life. I have added a word, design life. ये आपको समझ में आया? मैंने एक वर्ड ऐड किया. कौन सा वर्ड ऐड किया? Design life. Are you with me?
Yes, sir, we are.
Yes, sir.
So design life. So why design life is important? For example, if I were to design a metro bridge, if I were to design a metro pier for a life of 100 years, and let us say I have to design a building for life of 50 years. So इन दो स्ट्रक्चर में कौन से स्ट्रक्चर को डेडलीस्ट अर्थक्वेक आने की ज्यादा संभावना है? Can you answer this question? Probably which of the structures would have to sustain a severe earthquake compared to these two structures? The one which is designed for 100 years or the one which is designed for 50 years?
Yes.
100 years.
Sir, 100 years.
100 years.
So as your design lifespan increases, the likelihood of uncertain event and their severity also increases. Earthquake load, wind load, all these are uncertain loads. These are not certain loads. So if the design lifespan increases, the severity for which you are going to design the structure is going to be different. Do you agree with me?
Yes, sir.
Therefore, the structural designer must ensure that the structure remains stable and strong for its intended loads and purpose throughout its design life. So we must add this word design life when we define tasks for a structural design. Now, if I ensure that these two things are in place, is it enough? Or there is something more? Someone has already pointed out rigidity. So the fellow who has pointed out rigidity, can you unmute and tell me what do you mean by rigidity? किसने बताया था रिजिडिटी? प्लीज अनम्यूट, दिस इज अ डिस्कशन, डोंट बी अफ्रेड. कौन है, किसने बताया था रिजिडिटी? Okay, let us not point out. Let me ask any one of you, what do you understand by rigidity? So possibly Apurva, can you unmute? Is it Apurva or Apurva? No response in chat box, no response over microphone. I'm going
Sir,
to put the student on. Yes,
sir,
go ahead.
rigidity means how rigid the structure is. The term itself says.
But what is rigid? What is the meaning
Rigid
of word
means
rigid?
stiff.
Rigid means stiff. Okay. So yes. So often we use the words rigid and stiff interchangeably, but rigid is not stiff. Rigid is infinitely stiff.
Sir, rigid refers to the inability of a material to be bent even if a larger amount of force is being applied to it, or it also depends upon the resistance that the structure provides against force, which prevents it from getting deformed.
Correct. So you have talked about two things: a structure which is infinitely strong and infinitely stiff. Strong refers to it will not break under the any magnitude of load, and stiff refers to it will not deform under the any amount of load. So rigid is a imaginary concept. We say the structure is rigid when it is infinitely stiff and infinitely strong. Are you with me? However, when we talk about
Yes,
rigidity,
sir.
when we talk about rigidity, we do not refer to the structure being rigid, because that is technically impossible. No structure can be infinitely stiff, no structure can be infinitely strong. So when we talk about rigidity, we refer to a structure having finite amount of stiffness. Are you with me?
Yes,
Finite
sir.
stiffness.
Yes, sir.
More the stiffness, more is the rigidity. So rigidity doesn't refer to infinitely stiff or infinitely strong structure, though the word rigid is common in both this, rigidity and rigid, but rigidity means the stiffness. So instead of getting confused, we will replace this word rigidity by the word which we typically call it as stiffness. Are you with me? Now,
Yes, sir, we are.
yeah. Can you now tell me why this stiffness is so important in design? Because till now we have talked about the structure being stable. We have talked about the structure being strong under the deadliest combination of loads. We talked about making the structure stand these loads by designing the material, proportioning the geometry and its orientation optimally. ये सब करके हम उसको strong बनाने वाले. What about the stiffness? Till now we have not tossed the word stiffness, but you have undergone two courses in design. One is steel design, design of steel structures. Another is design of RCC structures. How did you take care of this stiffness stuff? Tell me. I'm waiting for response. Anyone can unmute and let me know.
So could you repeat the question?
So we have talked about the structure being stable, we have talked about the structure being strong, but we have not talked about the structure being stiff till now. But you have already undergone two courses. One is design of steel structures, another is design of RCC structures. So while doing the tasks of design there, how did you incorporate this stiffness in your design philosophy? ऐसे क्या किया था कि आपने ascertain किया था कि structure is enough stiff?
So the structural members should be stiff
How did you ensure that in RCC and steel design? Did
by
you talk
giving
about,
reinforcement.
pardon?
Reinforcement.
So did you design the reinforcement for moment, shear force, or did you design it for it making it stiff? You designed it for moment and shear, carrying shear force, right?
Yes, sir.
Yes,
So you
sir.
were designing the reinforcement for making the structure strong. Where is the stiffness coming in place?
Uh,
Sir,
deflection.
stiffness depends upon the material that we selected to put in as the reinforcement of the
Okay.
member.
Okay, so I will have a counter question. Let us say you have to design a beam for carrying the moment equal to 200 kilonewton meter. So you have designed its cross section. Now you need to design its reinforcement. So I select M20 grade concrete and Fe415. I get number of bars, bar diameter. But I could as well select M30 and Fe500. I will get different number of bars with different diameters. Do you agree with me?
Yes, sir.
Yes, sir.
Yes,
And
sir.
both the solutions are acceptable. तो stiffness को explicitly आपने कहाँ check किया? Where did you check whether the structure is stiff or not?
Deflection and torsion.
The lateral deformation, sir.
Yes. So now we are talking. So we call this as serviceability, isn't it?
Yes, sir.
Yes, sir.
So we wanted the structures to be serviceable. Serviceable का मतलब क्या है? Serviceable, in fact, is a vast terminology, but we will try to understand all aspects related to serviceability. So, for example, you are standing on a footover bridge on a Pune station from platform number 1 to platform number 3. When train passes below it, do you feel the vibration? Tell me. Do you feel the vibration of the bridge? Have you ever experienced that?
Yes, sir. We do feel a bit.
Would you like your floor slab where you stay to vibrate like that under various loads? Let us say there is a car passing on a road and your floor vibrates. Will you feel safe?
No, we would
No,
not.
sir.
So therefore, the serviceability is contextual. We can permit those vibrations on footover bridge. We cannot permit those vibrations on residential building. We cannot permit those vibrations on a hospital building. Hospital building में तो और ज़्यादा strict है because you have a CT scan machine there. If your floor itself vibrates to that extent, it is going to mislead. It is going to mislead the results, isn't it? Every equipment that the hospital has, for example, you can have a brain scanner, CT scanner, it comes with the prescribed limit of vibrations that it can sustain. So you have to design a building in such a way that the floor vibrations do not exceed that threshold. So therefore serviceability is contextual. Do you agree with me?
Yes, sir.
Okay, now let me give you another example. This is building number 1 and this is building number 2. It is located in a crowded area and the gap between the building is delta. And imagine this building is subjected to ground motion, something like this. So earthquake occurs. I am plotting ground acceleration on y-axis and time on x-axis. So in fact, this ground moves in to and fro direction such that the acceleration signal is of this fashion. And imagine for a particular case, this building deforms in this fashion and this building also deforms in this fashion. So there is all likelihood that these two buildings are going to hit each other, one another. Are you with me?
Yes, sir.
Yes.
So this phenomena is called as pounding of buildings, where the building did not fail because it could not sustain the earthquake signature. ऐसे नहीं है, वो earthquake को तो sustain कर सकता था, but because adjoining buildings में deformation इतना कम है, and we did not design the stiffness of building properly, that delta got exceeded, and buildings were vibrating out of phase, so they did collide over one another, and then there is a structural damage. So in this particular example, again, I am pointing out the importance of designing the structure in such a fashion that it has required stiffness. Are you with me?
Yes, sir, we are.
Okay. So stiffness requirement needs to be looked at from the point of view of serviceability. It needs to be looked at from the point of view of this pounding phenomena in particular cases. Now imagine the another scenario. There is a fire outbreak in a building. Due to elevated temperatures, what happens to the moduli of steel and concrete? क्या होता है एलिवेटेड टेम्परेचर में? क्या 5000 रूट एफसी के इतना ही मॉड्यूलस रहता है? 200 जीपीए इतना ही स्टील का मॉड्यूलस रहता है या कम होता है? बताओ.
So it decreases, sir.
So if the modulus is sensitive to the temperature, if there is a likelihood of outbreak of a fire, and you have not designed the structure properly, what is going to happen? Due to this elevation and
Deformation.
excessive deformations are going to occur, and within no time the structure will come down. Are you with me?
Yes, sir. Yes, sir.
So this maintaining the structure stiff even at elevated temperature may be the requirement for few of these structures. So I am just touching upon the various aspects where you will require to properly proportion the stiffness of the structure. Are you with me?
Yes, sir.
Yes, sir, we are.
Let me give you one more example. Imagine that this is a building plan. This is building plan, and let us say that it is a mall building. So on ground floor, this entire area has a horizontal circulation, but as you come up, there is a through and through duct. इस building में ये पूरा open to sky है. Are you with me? And only you are going to have passages and shops in this area. Are you able to imagine this?
Yes, sir.
Multiplexes or whatnot. Everything is occupied only in this area, and this is full duct. And imagine that more mass of the building is concentrated in this zone. More mass is concentrated here. And imagine the earthquake occurs in this direction. So therefore, as the more mass is concentrated here, the inertial force will be deflected towards the left of the building. Do you agree with me?
Yes, sir.
However, the center of stiffness is here. So resistance will be offered from here. What does it cause? It causes torsion, isn't it?
Yes, sir.
So even though the earthquake occurs in this direction, you will see the building twisting in plan as a response to the earthquake. This is because the difference between or having different locations of center of mass and center of stiffness of the building. So therefore, how do you proportion stiffness is another example. So in all these examples, I have highlighted the importance of providing a particular stiffness in particular fashion to a building. So what is the task at the disposal of a designer? He must ensure that the structure is adequately stable, adequately strong for deadliest load combinations it would ever encounter during its design life. And he or she should also ensure that the structure is serviceable throughout the lifespan for any scenario that is envisaged. Are you with me?
Yes, sir, we do.
Yes,
Okay.
sir.
Now, so I have listed down three primary tasks of a designer here, and that's how we define a structural design. However, this list also is unending. The design philosophies change, and the tasks at the disposal of structural designer also change. In some time, we will also talk about displacement based design or performance based design. Then this task will be slightly altered, and the list is unending. However, in the nutshell, these are the three tasks that we have to carry out as a designer. Now, uh, let us go ahead. The discussion can go on and on about this. We will fine tune this definition as we go along in the course. Now, let us talk about the formwork. So, formwork, do you agree that it is a temporary provision till the time concrete gains the strength, or till the time the structure gains its entire strength? The formwork is a temporary arrangement to support the structure. Do you agree with me? Formwork and shuttering.
Yes,
Do you
sir.
agree with me? Okay. So what will be its design life? Its design life is going to be very short. Do you agree with me?
Yes, sir.
But if you take into account reusability of the formwork, you have to use that formwork for multiple sites. Then again, its design life and load repetition cycles that it has to sustain becomes different. Do you agree with me?
Yes, sir.
तो यहाँ पे हमने और एक चीज भी ले सकते हैं यहाँ पे जब when we design a structure we also may need to design it for fatigue. So what is fatigue? For example, you must have seen the train track sleepers. देखे आपने दो रेल्स को कनेक्ट करने वाले स्लीपर्स देखे ना, एक रेगुलर इंटरवल पे रखे रखे रहते हैं. Are you with me?
Yes, sir.
Yes, sir.
When train passes over it, the sleepers are stressed. When the train goes, then the sleepers are unstressed. So it is in comparison with other structures, it is subjected to repeated cycles of load each day. Do you agree?
Yes, sir.
And fatigue is degradation of strength and stiffness on account of repeated load cycles. After certain number of cycles, after certain number of train passages, you need to replace these slippers. Why? Because it would have reached its fatigue life. So even to understand all these complicated phenomena and design the structure for it is designer's task. तो आप जरा देखो सबसे पहले डिजाइनर को क्या इन्विसेज करना है. What is the worst combination of load that the structure is likely going to be subjected to throughout its design life is the most challenging task that the designer has to do. Your structure is only that good जितना आपने load combinations envisage किया है. For example, just give me a second. For example, all of you are aware that when the World Trade Center did fall, it was not designed for the excellent plane crash loading. अगर डिजाइन किया रहता तो वो स्टेबल रहता वहां. Are you with me?
Yes, sir.
Yes, sir, we are.
Structure is only that strong जिसके लोड्स जो लोड्स के लिए आपने उसको डिजाइन किया है. If it is subjected to unprecedented or unimagined load, then it is going to suffer. So therefore, the foremost task in designer's hand is first of all to envisage all the loads that the structure is likely going to have during the design life. So enough for design now. So 2 points I wanted to stress. The definition of design is structural design is ever evolving. However, it deals with the three primary tasks. One is to make the structure stable, another is to make it strong, and another is to make it serviceable. And the last point that is important, by respecting economy. तो अगर स्टेबल स्ट्रॉन्ग एंड सर्विसेबल ऐसे 10 ऑप्शंस आपके पास अवेलेबल है, you are going to go with the most economical option. However, economy comes later. You cannot compromise stability, strength, and serviceability for economy. That comes later. For all 10 competent options as far as stability, serviceability, and strength is concerned, then you can choose the most economical one. Am I very clear?
Yes, sir.
Okay. Having said that, now let us go ahead to how do I ensure that the structure is strong and serviceable. So to have a look at it, we are going to understand cause and effect pairs. So what are the various actions, that is cause, that a member is going to be subjected to, and what are its effects? How do the member responds to it? So you are going to always look at cause and effect pairs in uh, cause and effect pairs in togetherness. Are you with me? Are you with me?
Yes, sir, we are.
Okay. So now let us try to list down various actions. So there are principally two actions. One is force and another one is moment of a force. Do you agree?
Yes, sir.
So there are principally two actions that we deal with. Typically one is force and another is moment. What are the effects? What does force do? Can you tell me? Anyone can unmute and let me know. What are the effects of forces? Okay, so I'm going to
So we can have either direct stresses or bending developed.
no, don't
depending
jump
on
to stress directly. Tell me, are you able to visualize stress? समझो आप बिल्डिंग का कॉलम देख रहे हो तो उसमें कौन से क्रॉस सेक्शन पे कौन से पॉइंट पे कितना स्ट्रेस है. Can you visualize that? No. So tell me the effects which you can visualize. What are the effects of forces?
Sir, failure of the structure.
Yeah, that is the extreme effect. But when you apply force on a structure, it did not fail always. If it doesn't fail, what
There
happens?
is cracks and
Formation.
there's a time
deflection.
which is breaking point.
So crack, breaking, all that is related to failure. Now tell me something different.
Deflections, sir, deflections.
Deflections. Now there you are. Now I am going to start my video. Let me know if I am visible.
Yes, sir, you are.
Okay. Now just have a look at this pen, and I am going to apply a force on this. Or simply if I drop this pen down, there is a gravitational force acting on it, isn't it?
Yes, sir, it is.
Now look at this and tell me what is the effect. What was the effect of gravitational force? Bolo. You observed it. क्या effect है? Did object move in the direction of gravitational force? Tell me.
Yes, sir.
Yes.
So what do we call this movement as? We
There
call
is
it as
displacement.
translation. Translation. Are you with me?
Yes, sir. Yeah.
So translation in the direction of the force is the effect of force. First effect of force. Now, when this object did translate, was there a change in distance between any two molecules randomly chosen? अगर मैं कौन से भी दो molecules इसमें से randomly choose करता हूँ, तो क्या उन दो molecules में distance जो था उसमें change आया है as this body translates, or that distance remains same?
Sir, it is
Remains
same. No
constant.
change at all.
So therefore we call such type of motion or such type of movement as rigid body translation. Why do we call it as rigid body translation? Because there is no change in the distance between any two molecules that we have randomly chosen from a body during its translation. Are you with me?
Yes, sir. Yes, sir.
So what are the effects of forces? One of the effect is rigid body translation in the direction of force. Do you agree with me?
Yes, sir.
Yes, sir.
Now look at this and tell me what is the effect. There is one force acting from this side, there is another force acting from this side, and now tell me what is the effect of this force.
Compression.
Compression,
Yes.
yes.
Compression है ना, but now what is the difference between the earlier effect and this effect? Now when the body compresses, if I randomly choose two molecules on this body, उनके बीच में जो distance है, is it going to remain same or is it going to change?
Change, sir.
It will change
Change, sir.
depending on the magnitude of the force.
Right, absolutely. So therefore, we call such type of translation as relative translation. Are you with me?
Yes, sir.
So what are the effects of forces? There are two effects. One is rigid body translation and another one is relative translation. Do you agree with me?
Yes, sir.
Yes, sir.
Okay. So this is the cause and effect pair. The first one, action is force, effect is rigid body translation or relative translation. कौन से direction में? Of course, force के direction. Are you with me?
Yes, sir.
Yes, sir. We are.
Now, tell me, if I toss a word moment of a force, what are the effects of moment? जिसको हम moment of a force कहने के बजाय couple moment भी कहेंगे. So whenever I am talking about moment, I am talking about moment of couple of forces, and that is couple moment. तो फिर से वीडियो ऑन कर रहा हूँ. Let me know if I am visible.
Yes, sir.
Yes, sir.
You
You
are
are
visible.
visible.
तो अब जरा देखो, मैं दो तरीके के फोर्स इस पेन पे अप्लाई कर रहा हूँ. कौन से फोर्स है? The one force is pushing it down, another force is pulling it up, but these two forces are placed at perpendicular distance. उनके लाइन ऑफ एक्शन में डिस्टेंस है. Do you agree with me?
Yes,
Yes,
sir.
sir.
Yes.
जितने अमाउंट से मैं इसको प्रेस डाउन कर रहा हूँ उतने ही अमाउंट से प्रेस अप कर रहा हूँ. कॉन्सिक्वेंस, देयर इज नॉट गोइंग टू बी एनी ट्रांसलेशन. जितने अमाउंट से प्रेस डाउन कर रहा हूँ उतने ही अमाउंट से प्रेस अप है. So therefore there is no question of translation. Do you agree with me?
Yes, sir.
Yes, sir. We agree.
So what is the effect? Bolo, what is the effect of this pair of
Rotation.
forces? Pardon?
Rotation.
Rotation.
Rotation. और किस तरीके का rotation? As the body rotates, are you going to see that the distance between two randomly chosen molecules is
Rigid
going to be
rotation,
risen
sir.
or is it going to change? बोलो.
It
Same,
will
sir.
remain the same.
हाँ, सेम रहता है. तो इस तरीके के रोटेशन को हम क्या बोलेंगे? Rigid body rotation.
Rigid body rotation, yes.
So what is the effect of movement? Tell me. Rigid body rotation is one of the effects. Do you agree with me?
Yes, sir.
Now,
Yes, sir.
I am fixing this side and I apply this pair. Now what is the consequence? This is going to bend. Do you agree with me?
Yes, sir.
Consequently, the upper face is going to be subjected to tension and lower face is going to be subjected to compression. Just bend your neck like this. You can feel this side is going to be subjected to tension and this side is going to be subjected to compression. Do you agree with me?
Yes, sir.
And distance between any two randomly chosen molecules on my neck, is it going to change or is it going to remain same?
It will change, sir.
चेंज. सो इस तरीके के इफेक्ट को हम क्या बोलेंगे? इट इज रिलेटिव रोटेशन. Are you with me?
Yes, sir.
Two cross sections, they rotate relative to one another, so that the distance between any two randomly picked up molecules or cross section, two cross sections, it doesn't remain same. Are you with me?
Yes, sir.
Yes, sir.
So relative rotation.
Yes,
चलो
sir.
अब बताओ, ये जो रिजिड बॉडी रोटेशन है और ये रिलेटिव रोटेशन है, कौन से प्लेन में होगा? इन विच प्लेन डज दिस ऑकर? तो देखो, इफ मोमेंट का प्लेन ये है, दिस इज द प्लेन ऑफ मोमेंट, then rigid body rotation is going to occur in the plane of moment. Do you agree with me?
Yes, sir.
If this is the plane of moment, then rigid body rotation is going to occur in the plane of the moment itself. Do you agree with me?
Yes, sir.
Okay, so now I will stop video and I will write down moment के दो effects है. One is rigid body rotation and relative rotation in the plane of moment. Are you with me?
Yes, sir.
In the plane of moment. Okay, and force के दो effect है, rigid body translation and relative translation along the direction of force. Do you agree with me?
Yes, sir.
तो ये तो समझ में आया कि हमें कि फोर्स क्या है, मोमेंट क्या है, उसके इफेक्ट्स क्या है. अब मुझे एक चीज बताओ, in your reinforced concrete design and in your steel design, did you design the structure for force and moment or did you design it for axial force, axial compression, axial tension, bending moment and twisting moment? किसके लिए डिजाइन किया? सिर्फ मोमेंट के लिए डिजाइन किया या फिर ट्विस्टिंग मोमेंट या बेंडिंग मोमेंट के लिए डिजाइन किया? बताओ.
Twisting moment and bending moment.
Did you design the structure for force or did you design it for axial force and shear force? किसके लिए किया डिजाइन? फोर्स के लिए डिजाइन किया या एक्शियल फोर्स एंड शियर फोर्स के लिए डिजाइन किया?
Axial and shear force.
So therefore we now need to distinguish between the actions for which we need to design a structure and force and moments which are in general labeled as actions. इनमें differentiation करना अभी अहमियत रखता है. Do you agree with me?
Yes, sir.
So what are the four basic actions that we design the structure for? So one, I am going to call it as axial force. Another, I am going to call it as shear force. So these are the two force actions. Are you with me?
Yes, sir.
And one we are going to call it as twisting moment. Twisting moment. And another, I am going to call it as bending moment. Are you with me?
Yes, sir.
So in next class, approximately 2 to 3 classes I am going to spend only on this revision. So once we are in place with all these concepts, then only there is a point in talking about the design. If you feel that these concepts are very preliminary and you already know it, please let me know at the end of this class so that we can swing these 2 classes and we can straight away go with the subject matter. Okay. Now having said that, now we need to understand how is axial force and shear force different than a force. And how is twisting moment and bending moment different than a moment? And what are the corresponding responses or what are the corresponding effects? So that's what we are going to do in next class. We are now going to understand cause and effect, cause axial force, shear force, effect. Then cause twisting moment, bending moment and its effect. So we are going to define all these four actions in next class and their effects. Are you with me?
Yes, sir.
Now trailer for the next route, we are going to then define what do we mean by analysis. Are analysis and design independent tasks or are they interrelated? Do we do rounds of analysis and design, iterations of analysis and design to arrive at the final solution, or are these one time tasks for a structure? ये सब हम next class में discuss करेंगे. Okay?
Okay, sir.
Okay. So with
Yeah.
this, let us close today's class. Have a good day. I will share attendance link in a while. So once I share that, you have to fill it within next 5 minutes. And that link will be always open. So I will open it only for the class duration. So during the next class, you can fill that form for the attendance of that class. Chalo. So with this, let us close for today.
Sir, we didn't got our roll number yet.